Hey everyone, this is Andy Melbuff, and in this video we're going to continue looking at how we can check responses from students in the teacher dashboard of Desmos Activity Builder by using some computation layer. In this example, we're looking at the preview of a graph component and asking students to drag one or both of those movable points to make a line that has a slope of -3. Now your dashboard check right now shows an X because clearly this line doesn't have a slope of -3. But if we were to do a little manipulating of these points, like so, there we get a check now. Now we don't have to move just one point or the other, we can move a combination of them as long as the slope is going to be -3. So how do we build that into the computation layer? Well, let's go out of preview mode and we'll take a look. In building this from scratch, I put a note component in here with the directions, and then we want to build the graph component. So I want a couple of movable points. So I prefer to use A comma B initially as an initial movable point ordered pair. And I'm going to add those two sliders. And I'm going to make some adjustments on those sliders to make this a little more convenient for me and students to take a look at. I'm going to make their steps 1. So just by doing that little bit right there, you can see that we can move this point anywhere we want, and it moves in increments of 1. And we could throw a label on there, and that point's ready to go. So I want to do something similar with a second movable point. So I'm going to use C comma D. I'm going to add those sliders. I'm going to make their steps increase by 1, just as I previous did. And I want these 2 points to have the same color, so I'll go ahead and make them both red. Now, the second point doesn't look like it's showing up there. That's because I haven't moved it yet. There are 2 points. Now what I need is I need to represent slope, because this is all about slope. So in mathematics, we typically use M for slope, so I'm going to use it here. And I'm going to set up basically my equation to find slope. So slope is defined as the difference in the y's divided by the difference in the x's. Well, I have those up here in terms of my sliders. So in terms of difference of y's, I can use D minus B because D and B are the sliders representing the y values. And then I would use C minus A for the x value amounts. So right now, based on where my points are, it says there's a slope of 0.5. If I make the two horizontal with each other, you can see the slope there is 0, and there's a negative slope, and watch what happens if I stack them vertically. We get an undefined slope. So my slope is all set right now. What I also want to do is graph an equation to go through those lines so the students can visually make that connection with not just points but a line going through them. So I'll use point slope form here, where I'm going to use basically y minus, and I'll use D. And there you can see there's point slope form, and you can see a blue line going through my 2 points. And let's see, I think we're about ready to go. So the last thing we need to do is check for correctness, and we'll do that in a computation layer. So I'm going to go over here, and I want my slope to be -3. So we're going to define a number -3, and I want that to be M. Oops, I forgot my correct. Sorry about that. I want the correct to be M to be -3, and so I just simply type that in as we've done in other situations. So the correct check is saying, is this number M in this component going to be -3? So let's check it out, preview mode. There's a -3 slope, and as you can see, we get the check. So I probably need to do a little zooming here, but anyway, that's how we can get the correct check all set for that particular situation. Now on this screen, we may want to ask students to input their own graph rather than just move points around. So how do we judge the validity and the correctness of their graph that they type in? Well, for example, in matching that graph, what if a student types in y equals x squared? Well, visually, they can get some feedback here, but in terms of the teacher dashboard, we want to be able to see that it's right or wrong. And here you can see that I've got an indicator in here that it's wrong. And if they were to type it in correctly, and I have my squared in the wrong place. If it's typed in correctly, the dashboard indicator goes to a check mark. So let's look at the background and see how we can engage computation layer to give us this check. Okay, the first thing we want to do is put our graph together. So I had this built kind of already. I'm going to go ahead and delete part of it. And I'm going to insert an expression. And the first thing I want to do is, what do I want the students to see? So I'm going to call this a function. We'll call it f of x. And let's say I want it to be the function x minus 3 quantity squared. And that's what we saw before. Now, if I want students to match that, I typically will change my graph a little bit. I might make it dashed or dotted, something like that. But that's ready to go. That's what the students will see. Then below that, I want to create another function. I'm going to use g of x. But for right now, I'm going to leave g of x like that, meaning it's not defined, because I want the student's input to be connected to that via the computation layer. So if I click on the add slider, you'll see a graph shows up, and I only do that just to make sure that I get a color in there that's different than the initial one. But I don't want that slider to stay. I'm going to keep this function undefined until the student inputs something into their answer box. Now, this part here I kept from before because I don't want to mess it up, and so I want to make sure I keep it in here clearly. What I'm highlighting is I'm going to create a list of values. And I use a capital letter there. I chose X. And I want my list of values to go from -5 to 5. So it's all the integers, 11 integers from -5 to 5. And what we're going to do is we're going to set up a check. I want to know if between my two functions, between what I have and what the student inputs, I want to know how much difference there is between them. So here's how we do that. G of x is what the student is going to enter. Now the capital, notice there's a capital X there. That's using one of the values from my list. Is the difference between the student's function and my function going to be close to 0? That's ideally what we want. So we're going to use absolute value. Notice the absolute value surrounding that g of x minus f of x. And then I want to find the total of those. So basically we're doing 11 different checks because I have 11 different data points in my list. And we're going to check the difference of those 11 in the two functions. And we're going to total them up. And ideally, if my total is 0 right there, that's what we desire. That's a clean match. And so if the total of all those differences is 0, then C gets assigned a value of 1. And if they're not 0, then C is assigned a value of 0. So that's our correct check. This C is our correct check. That's what we're going to check for. Now, in terms of the computation layer, I need to define the function f over here. So, or I'm sorry, g over here. So I'm going to use function. I'm going to call it g, and I'm going to use simple function again. And I want that simple function to come from the input using the LaTeX, the student's LaTeX there. And also, I'm going to jump down and I'm going to make this read only, because my correct check is only going to be based on C. We're not going to have anything else going on in here. So I only want to read only in that graph, because down here in my input component, here's where I'm going to put my correct sync, not capture. My correct sync is going to go from, now I got to tie this into the graph, so I'm going to close right out of there. I've already titled this component graph, so that's going to be the component I tie it into. Graph, and then from graph, what do I want? I want the number C, and I use capital C because I did in the graph, and I want that to be equal to the number 1. So let me put a little space in there. So this is going to be our correct check, and let's see how it works. If the student in preview mode types in x minus 1, quantity squared. That's not a squared. Quantity squared, you can see visually they get their parabola, and they can see they're wrong, but the teacher gets the x. That's because the list of 11 values gets substituted into both the student's version and the teacher's version, and there's a difference in scores there, a difference in values there. So if the student changes this to a 3, visually they get that, and the teacher gets the check. And this last scenario we're going to look at in this video anyway is going to look at what if we want to do a couple of checks on points or things like that. Can we combine them together? So this one's a little bit more sophisticated, and what you see here are two ordered pairs. One's at -2, -5, and the other's at 1, 1. And we are asking students to build a function that goes through both points. Let me give you an example of something that might work. Maybe it doesn't. If a student types in y equals x minus 5, you can see clearly there's feedback for the student here that it's not going through both points. But on the teacher dashboard, we can also have an indicator. So there, if the teacher is watching the entire class, they see that x. So if we change it to 2x minus 1, visually the student gets what they need and the teacher gets a check. So how do we get this check, this correct check, to show up in the teacher dashboard? Let's exit preview mode and find out. Now, similar to what we had before, I want to work with the graph first, and I want to have a function graphed. So I typed in f of x, but I left it just open like that. Desmos can't graph it. It doesn't know what f is. I'm going to tie this function f into the student's input using the computation layer. So I'm not even going to add the slider. If you want to add a slider to check the color of the line, that's great, but you don't need to. Then I'm adding a table here, and this table contains the two ordered pairs that I wanted to put in. My first column has my x sub 1 values, those are my x coordinates, and then here's really what I desire the student to have, is the equation 2x minus 1. So if I type it in right there, you can see actually we can get other ordered pairs. If I type in a 2 here, we get 3 points. I mean, you can have as many as you'd like. I'm going to leave it with just 2. And I have that colored blue. And also I increase the size so that the students see that big open circle there. Now below that are the correct checks, and I can pull those really right out of the table that we were using above. Here's how. I'm going to have correct check number 1. I want to know if the student's line goes through the first ordered pair. The first ordered pair is at -2, -5. So I want to know if C1 has this function input output. I want to know if the line goes through the ordered pair -2, 5. If -2 is input into the function, is -5 the output. I want to know if that's true. If that is true, then we're going to assign C sub 1 a value of 1. If it's not true, we're going to assign C sub 1 a value of 0. So we're going to have a correct check C sub 1 pertaining to this ordered pair right here. And then we want our line to go through the other one also. So we're going to have a second correct check. And we want, when we input 1 into the function, the x coordinate of 1, we want a y coordinate or an output of 1. If that happens, then we will have a 1 for our C sub 2 value, otherwise we'll have a 0. And then to tie those two together, we're going to multiply them, because if we're talking about zeros and ones, if they're both correct, 1 times 1 is going to give us a 1. And if either one's a 0, if either one's incorrect, then C, capital C, the total correctness, is going to be 0. So I'm all set there. I need to go into my computation layer. I need to define function f. And like before, I'm going to use simple function from the input, choosing its LaTeX as the source. And I'm also going to make this read-only. I set that equal to true so that Activity Builder is not checking the graph, it's going to check the input, and that's where I'm going to put my correct check. So jumping into the computation layer here, I'm going to use my correct sync. I'm going to tie it to the graph as its component. I want the number, like we did before, capital C, and I desire for that capital C to be equal to a value of 1. So that is how we can combine a couple of individual correct checks for ordered pairs into one overall slide correct check. Thanks, everybody.